Good morning. Good morning. Hope all is well. Hope everyone's doing all right. Still got somebody trying to connect with their audio. So we'll give them a few seconds. Josh. Sorry about that. Let's see. So I was looking at you guys' assignments. Give me 1 second. We did functions. Okay, we talked about exponents last class. Add, subtracting. So we're looking at multiplying exponents today. Multiplying polynomials today. All right, so before we get started on anything, did anybody have any questions? Have any questions on anything? Negative exponents, multiplying exponents. Here we go, 12.3. Multiplying polynomials. Last class we ended with adding and subtracting polynomials. And today looking at 12.3, multiplying polynomials. All right. So when we're talking about multiplying polynomials, let's look at just multiplying single terms. We have 3x to the fourth times 4x squared. So you multiply what you can together. So 3 times 4, and then x to the 4 times x squared. And so that's what I did right here. 3 times 4 is 12. Then x to the 4 times x squared. You add your exponents. That'll be x to the 6. All right. Any questions? Next one. We have a negative 4c to the 5th d times 2c squared d cubed e. So negative 4 times 2. And we have c to the 5th times c squared, then d times d cubed, and then e could then have another e term to multiply 2. So we just leave it there. Negative 4 times 2 is negative 8. C to the 5th times c squared, add your exponents, c to the 7th. D, assume you know there's a 1 there for the exponent. So there's 1 plus 3, and that'll give you 4. All right, questions? Any questions? Sorry about that, one of your classmates trying to get in. All right, so now we have 2x times 4x minus 3. So you distribute the 2x into the parentheses. So you do 2x times 4x, 2x times 3. So that's what I emphasize right here. So 2x times 4x, 2 times 4 is 8, x times x is x squared. Then 3 times 2x is just 6x. Any questions? Any questions? All right. So next one, negative 3a squared minus times negative 4a squared plus 2a minus 1. Distribute the negative 3a squared to each term. So you have negative 3a squared times negative 4a squared. That will be a positive 12a to the fourth. Negative 3 times negative 4 is positive 12. A squared times a squared, a to the fourth, just adding your exponents. Then negative 3a squared times 2a is negative 6a cubed. Negative 3a squared times negative 1 is positive 3a squared. Questions on that one? All right, here we have two binomials, x minus 7 times x plus 2. All right, so we're going to distribute. We have x, you're going to distribute into the other parentheses, take the negative 7, do the same. So x times x will give you x squared. X times 2 will be 2x. Negative 7 times x is negative 7x. Negative 7 times 2 is negative 14. Then from there, combine your like terms. 2x minus 7x is negative 5x. Questions? Any questions? All right. So here we have y minus 2 times 3y squared plus y minus 5. So we're going to distribute just like we did before. We're going to take the y, multiply to each term. In the other parentheses, then we'll take negative 2, multiply to each term as well. So y times 3y squared is 3y cubed. Y times y is y squared. And then y times -5 is -5y. So right here, go right here in our multiplication. Then take -2 times 3y squared, which is -6y squared. -2 times y is -2y. -2 times -5 is +10. Then from there, combine your like terms. 3y cubed couldn't be added to anything. Y squared and -6y squared is -5y squared. -5y, -2y is -7y. And then 10 couldn't be combined with anything, so we just bring it down as well. All right. Any problems? Any problems? All right, next one, 2x plus 3, 2x minus 3. These are called conjugates. Whenever you have just the middle signs different, they're considered conjugates. So whenever you're multiplying conjugates, after you do your distribution, notice here we have 2x times 2x, which is 4x squared, 2x times -3, which is -6x, 3 times 2x is 6x, and then 3 times -3 is -9. So whenever you multiply conjugates, what's going to happen is that your middle terms will be the opposite, and they will always cancel out for you. So that will always be the case. All right, trying to splash back. There we go. So 6x and -6x cancels in the middle, and that leaves you with 4x squared minus 9. Any questions? So here we have 1/2 x plus 6, 1/2 x minus 6. So once again, we're going to distribute. 1/2 times 1/2 is 1/4. And so I did the work over here, just showing you 1/2 times 1/2. You just multiply ones together, multiply twos down bottom together to give you 1/4. And then right here, 1/2 times 6. Talking about half of 6, that's 3. But if you had to do the math, we'd operate the same way, multiply across, 1 times 6 on top, 2 times 1 on bottom. And then 6 divided by 2 ultimately gives you 3. So that's what happens in the middle. So we have 1/4 x squared minus 3x minus plus 3x. And 6 times -6 is -36. Any questions? Any questions? 3x is canceled. 1/4 x squared minus 36. All right, next one, 3w minus 4. So what we cannot do here is take the square and apply it to each term because of that minus sign. So what we would have to do here is expand it out like I did here. That's 3w minus 4 times 3w minus 4. And if that's the case, now we do our distribution, 3w times 3w, 9w squared, 3w times -4 is -12w. -4 times 3w is -12w, -4 times -4 is +16. Any questions? Any questions? Let's do it again. Here we have 5x squared plus 2 squared. So that's 5x squared plus 2 times 5x squared plus 2. Do our foiling distribution. So this 5x squared times 5x squared is 25x to the fourth. 5x squared times 2 is 10x squared. 2 times 5x squared, 10x squared, and then 2 times 2 is 4. Then combine the like terms in the middle. I don't know, did I finish this one off? Anyways, so yeah, anyway, we see the work here. 12w minus 12w. -12w minus 12w gives -24w plus 16. I don't know, for some reason I feel like I finished that off. But anyway, here, combine the like terms in the middle. 20x squared. We get in the middle with our like terms. And so it's 25x to the fourth plus 20x squared plus 4. All right. Any questions on multiplying polynomials? All right. So we have one more section out of chapter 12. We can go ahead and knock that out. And then we'll talk about how we're going to move forward. All right, so 12.5 is negative exponents in scientific notation. All right, so we talked about negative exponent rules. Previous class, a to the negative n power is 1 over a to the n if you want to write it as a positive exponent. 1 over a to the negative n, to write it positive, you take it up to your numerator. That's a to the n. Then if you have a fraction being affected or have a negative exponent being applied to it, the negative will make you flip the fraction. So it goes from a over b to b over a, and then we have a positive exponent. All right. So if the directions say simply write using positive exponents only. We have 3 to the negative second power. If I want to write that with a positive exponent, drop the 3 to the negative second, 3 to the second down bottom to make it positive, and 3 to the second power is 9. All right, 2x to the negative third power. Don't forget, unless it has parentheses around the 2 and the x, the negative 3 is only applied to the x. So that's why that just goes down bottom and the 2 stays in the numerator. So that's 2 over x to the third. Now, if there were parentheses, that's what this example is. If there were parentheses around the 2 and x, then you would drop both the 2 and the x down bottom and turn the exponent to a positive. All right, then we have 2 to the negative first power plus 4 to the negative first power. So first thing we do is rewrite it as a fraction with positive exponents. So that's 1 over 2 plus 1 over 4. It just makes you drop your 2 down to your denominator. You drop your 4 down to your denominator. Then don't forget, if you're going to add fractions, you need a common denominator. A common denominator is 4. The smallest number that both 2 and 4 can divide into evenly. So to change the denominator to 4, I have to multiply it times 2, multiply it to the top and bottom. This is already have a denominator of 4, so we're okay. So that's 2 over 4 plus 1 over 4 gives you 3 over 4 as your final answer. Any questions? Any questions? Scroll up. Now, once again, if your negative exponents in your denominator, take it up to your numerator to make it positive. So 1/3 to the negative fourth would be 3 to the positive fourth power, which would be 81. It's 3 times itself 4 times. Then we have p to the negative fourth over q to the negative fifth. So since the p has a negative exponent in your numerator and the q has a negative exponent in your denominator, you just flip them, take the q up top, bring the p down bottom, and then rewrite it as a positive exponent. All right, next one, x over x to the negative second power. Once again, if all you see is that variable with no number, assume you know there's a 1 there. And whenever you're dividing your exponents, you're going to subtract. And whenever you're dividing your variables, you're going to subtract your exponents. So don't forget to make sure you don't leave out a negative. So notice the minus sign is your division. And then you have a -2 there. So that's 1 minus -2. And then negative turns positive. So that's why we have x to the third power here. 1 plus 2. Any questions? Any questions? All right, same thing here. We have a to the negative fifth over a to the seventh. Once again, make sure you don't lose the negative. So it's -5 minus 7. And that'd be -12 for your exponent. But if you're going to write your answer as a positive exponent, you drop your a to the 12 down to your denominator. All right, so next one. We have y to the negative third power, z to the 6, raised to the negative 6 power. All right, so now we need to distribute that -6 of exponent to each term. So now we have y to the negative third raised to the -6 power, z to the 6 raised to the -6 power. Then we're going to multiply. Whenever you're raising the power to a power, you multiply your exponents. -3 times -6 is +18. 6 times -6 is -36. Now to rewrite and make sure we write all of our expression with positive exponents. Oh, so that my eraser on. There we go. Z to the -36. Drop it down into your denominator. So it's y to the 18th over Z to the positive 36. Any questions? Any questions? All right. So we've got another one. So here we have -2x cubed y over xy to the negative first power, all raised to the third power. So gonna have to combine our like terms or like bases, I should say. So x cubed over x, y over y to the negative first power. So try to emphasize that here. So whenever dividing, you're subtracting your exponents. So that's 3 minus 1 for x, and then 1 minus -1 for y. And so we still have not addressed the 3 on the outside yet. But 3 minus 1 for x is x squared. 1 minus -1. That's what 3 minus 1 is x. I mean, 3 minus 1 is 2 for x squared. And then 1 minus -1 will be 2 as well for y. All right, now we can distribute this 3 of an exponent to each base. So -2 cubed, x to the second cubed, y to the second cubed. All right, -2 cubed is -8. That's -2 times -2 times -2. X squared cubed, you multiply your exponents, that's x to the 6. Y squared cubed, you multiply your exponents, that's y to the 6. All right. Questions? Any questions before we look at scientific notation? All right. Let's look at scientific notation. So scientific notation is used to express various extreme values. It is written in the form of a times 10 to the r power, where a is going to be in between 1 and 10. And notice we have here, this is inclusive. That means it can be 1, but it cannot be equal to 10. and then R is an integer. All right, examples of that is 1.23 times 10 to the fifth power, 7.8 times 10 to the negative 31st power. So notice the 1.23 is in between 1 and 10. And this is an integer for your exponent. Same thing here, 7.8 is in between 1 and 10. And negative 31 is an exponent, integer for your exponent. All right, questions? All right, so write each number in scientific notation. So first thing we'll do is locate the decimal. We have 367 million. We don't see a decimal, so they assume we know it's right here to the rightmost, or to the right of the rightmost digit. So we know that our decimal is right there. Now we need to move it to a place where it will create a number that's in between 1 and 10. So we'll put our decimal right here to make 3.67. If we were to put it right here, that's 36.7, which would be greater than 10. If you put it right here, it'd be 0.367, that's less than 1. So you're going to put it after the first number to create a number that's less than 10, in between 1 and 10. So when you look at moving that decimal, notice we took it 1, 2, 3, 4, 5, 6, 7, 8 to the left. We have to move 8 to the left. And so that gives me 3.67 times 10 to the 8th power. And we use a positive 8 that represents the fact that we had a very large number here. And if I were to multiply this back out, it would give me the 367 million. All right, so here we have 0.000005. Once again, to write in scientific notation, we need to locate the decimal. This time we see it right here. And we need to move it to a place that's going to create a number that's in between 1 and 10. So if we place it here or move it 6 times to the right, that will place it behind the 5, which will create a number that's in between 1 and 10. So it's going to be 5 times 10 to the negative 6. So we went to the right. That's a negative 6. That negative represents we had a very small number. So we should have a negative value. Then we multiply it back out, 5 times 10 to the negative 6. It will give you that small number again. All right, any problems, any problems? So here we have 20, 500, 000, zeros. So 209, 20, it would be 20.5 billion. Anyway, so once again, we look for our decimal and we see it to the right of our, it will be to the right of our value, rightmost digit, which is at 0. And you take your decimal, move it 10 to the left to create that number that's in between 1 and 10. So it'd be 2.05. So that gave us 10 to the left. So that'd be 10 to the 10th power. All right. One more like this, 0.00085, and we want to write it scientific notation. Move our decimal 4 places to the right to create the number 8.5. Once again, 8.5 is in between 1 and 10. So that gives us 8.5 times 10 to the negative 4th power. Any questions? Any questions? Any questions before we go the other way with it? Everybody okay? All right. So next one, we want to write using standard notation. So in other words, using it without exponents, we have 1.02 times 10 to the 5th power. So we're going to write that scientific notation value in standard form. So since it's a positive 5, we know we're looking at a large number. So we're going to take our zeros, our decimals, excuse me, and move it that many spaces to the right. So we have 5 here. So we will move our decimal 5 places to the right, and then use zeros for any placeholders for the spots that we do not see or do not cover. So that's 0.02. So that's the first 2 spots of the 5, and then we have 3 zeros that we will use for placeholders. So that's 102,000 for that number in standard notation. So do it again. This time we have a negative exponent, 7.358. So we're going to move our decimal 3 places to the left. Remember, this is going to be a smaller value than what we originally have. That is 7.3. So move it 3 places to the left. Use zeros as placeholders. And that's 0.007358. And so a lot of times people ask me about the zeros sitting to the left of the decimal. You don't necessarily have to do that. I'm used to doing that, doing 0.007. But you could have just done 0.007358 and it still would have been fine. All right, any questions? All right, so next one, 8.4 times 10 to the 7th power. All right, so move your decimal 7 places to the right. That'll be 84,084,000,000. One of those decimal places will be moved by the taken up by the 4. Then we use 6 zeros as placeholders. All right, one more. 3.007 times 10 to the negative 5th. So we move our decimal 5 places to the left. Give you 0.0003,007. Questions? Any questions? Everybody good? Everybody straight? All right. So next class, I will pause. Let's see. So that's 12. We got 13, 14. Yeah. I guess we'll be okay doing this. 13. Okay, so first of all, remember, we don't have class Monday. Celebration of Juneteenth, so we don't have class Monday. So trying to see if we can, because we just finished 12. Hold on 1 second. All right, so we got this to be. All right, so see, missing that day is messing me up. Well, let me think about it. Let me calculate some things as far as due dates. So don't forget, we've covered this content right here. And we covered chapter 10's content. We just finished off chapter 12. So at some point, if you haven't taken any tests, you do want to start taking tests. And remember, you can set up those times with Mr. Davis. I was trying to see if we had room to get a test in for class time, but I have to map this stuff out because we only have, I think next week will be 4th week. So it means we'll be 6 weeks after that. So just need to map this thing out and see. But make sure you get with Mr. Davis. Remember, his email address is jldavis@tcc.edu. So jldavis@tcc.edu. Also, make sure you CC me, vtucker@tcc.edu once you try to set it up. Yeah, because you got to get these tests in. So make sure you are getting yourself prepared. Remember, talk about it. I mentioned it last class as well. If you want to get properly prepared for the test, you have these test reviews. that will let you know pretty much exactly what's on the test. And you'll be able to study that to make sure you perfect those type of problems. And so it's a test review in front of each test. Set up like a homework, you do an unlimited amount of tries. All right. So that's it for chapter 12. Anybody have any questions on anything? Any problems you may have tried, gotten stuck on? Anything? All right, so everybody's good, everybody's straight. Okay, so as always, try the stuff out, see if you have any questions, see if any questions or problems are generated once doing your homework and everything like that. Every day is opportunity for questions. Every day is open for you to ask questions. And also don't forget we have office hours that you can attend to. Or if you need time outside of office hours, make sure you email me on that front as well so we can make sure you're taken care of. Other than that, you guys have a great weekend. Be safe, and I will see you on Wednesday. All right. Everybody take care.